Welcome to Hartman Math. This is lesson 1-1 where we're going to look at some patterns through the U-cubed platform. Kind of leading up to that, we kind of want to see how do we want to attack these kinds of patterns, how do we want to organize the information. So we're going to do that kind of through an example number 1 where it says, at Billy's birthday party at the end of 1 hour he had 7 balloons. At the end of the second hour there were 5 balloons remaining. And then at the end of the third hour, there were 3 balloons. So we're going to use this. Here's our problem. And we're going to do some things to organize some of the information there. First of all, we're going to make a table of values. From that, we're going to then plot the points to go with that. So to make the table of values, we're going to need to have some titles. So what are the quantities? What are the things that can be measured or counted that are changing in the problem? We also want to kind of figure out which one is the independent and which one is the dependent. So we've got independent and then we've got dependent. So which one depends on which? So what we've got is things that are changing in the problem: time or the hour. And if time is one of the quantities in your problem, I would say almost with a certainty that's going to be on the left side, your independent, which is kind of acting as our x variable for when we graph it as in the coordinate plane. So the hour is changing. Oh, also balloons are changing. So our count of balloons depends on the hour that it is. And we would say at 1 hour, 7 balloons. At 2 hours, 5 balloons. At 3 hours, 3 balloons. So we want to label the axes here. So if we're going to draw, I'm going to use a ruler, draw an axis here, and an axis here, and we would say basically the y value, that's going up and down, that's going to be balloons. So we label that. And then the horizontal is going to be our hour. And we can go right to plotting the points, label the axis. So we would say at 1 hour, 7 balloons. 1 to the right, 1, 2, 3, 4, 5, 6, 7 balloons. Right there. 2 hours, 5 balloons. 3 hours, 3 balloons. So we have a set of points based on our table of values. Next thing, is the function linear? Well, would these points appear to make, if we connected them, a straight line? I would say yes. Now, can we prove it? Well, when we prove it, we actually want to use the table to do so. So what we're looking at is, what are the differences in these x values? So the difference between 1 and 2 is 1. And the difference between 3 and 2 is also 1. And we did that by subtraction. But we have to be very careful that we subtract in the same order. Meaning, we did 2 minus 1. We basically subtracted going up the chart. So we need to make sure we do the same thing over here. So, for example, with the change in balloons, the difference in the balloons is not 2. We can't go 7 minus 5, which is subtracting in this order. We have to go the same order. We have to do 5 minus 7, and that's negative 2. And then we have to do 3 minus 5, that is negative 2. And what we're doing is we're examining, we're going to use this information to get a rate of change. That's what's going to prove that this is in fact linear, to get the rate of change. The rate of change, we do the change in y divided by the change in x. So it would be negative 2 divided by 1, and that's negative 2. Same thing here. Change in y divided by change in x. Negative 2 divided by 1 is negative 2. If the rate of change is constant, the same number, it's linear. So it's linear, yes, because the rate of change is constant, meaning it's the same number. So if we got negative 2 here and negative 7 here, it's not going to be linear. All right. Use the point-slope equation to write the equation of the function. It's a little poorly worded here. So we would want to start off with, well, what is that point-slope equation? And that point-slope equation is y minus y1. But I want to get us used to using function notation. So I'm going to replace y with f of x minus y1 is equal to m, standing for slope, times x minus x1. Now it turns out that the slope is the rate of change. As long as it's the same number, that becomes the slope because this is linear. So we know that our slope is negative 2. And as far as the rest of it, we get to choose any of these points. So maybe we choose the 2, 5. It doesn't really matter. It's all going to get us to the same place in the end. So we would say f of x minus the y coordinate of the point that we picked, that would be the 5, is equal to negative 2 times x minus the x coordinate of the point that we picked, that would be 2. This is our point slope equation. Now the next thing might be, well, let's see if we can get this into slope intercept form, which is essentially y equals mx plus b, because it gives us a little bit more information. So to get it into slope intercept form, we just got to do a little bit of an algebra, which is to distribute negative 2 times x, negative 2 times negative 2 is positive 4. And I want to get the f of x by itself. F of x is equal to, I'm going to add a 5 to both sides, so I'm going to add it here where there's a like term, negative 2x plus 9. There's my slope intercept form, which is y equals mx plus b, where we have slope, y, intercept. So, according to our equation here, what is the y-intercept? It's a point. So we would say something comma something. We can also look at it on the graph here. In fact, let's do that. So let's take our equation, our points, and turn it into a line. We said it was linear, so it would make a straight line. Something like that. So the y-intercept, where are we intersecting the y-axis? Right in here. Where is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. It is the point 0, 9. Now look at the equation. What do you notice? The b is the y-intercept. 9, 0, 9 for there. What does it represent in our problem? Remember, we have hours of, so 9, we're talking about 9 balloons. 9 balloons. When? What's our hour that is associated with that point? 0 hours. So when and the party have 0 hours expired, start of the party. So there are 9 balloons at the start of the party. What about the x-intercept? And what does that mean? So here's our y-axis, here's our x-axis. Where is our function? Where is our line crossing the x-axis? It appears it's right here. So where is that? 1, 2, 3, 4. Between 4 and 5. In fact, I think it is pretty much exactly at 4.5. So we don't do mixed numbers. What we could put is 4.5, comma, 0. Intercepts our points. X coordinate, Y coordinate. What does it represent? All right, well the 4.5, we're referring to which axis? The x-axis. What are we measuring? Hours. So we could say in 4.5 hours, what's happening? Well, there are 0. What's on this axis? 0 balloons left. It's 4.5 hours. There are 0 balloons remaining. Is the function increasing or decreasing? Well, you could look at your table. What's happening? You could look at the graph. What's happening? You could look at the situation. As time goes on, what's happening to our number of balloons? It's going down. That would mean it's decreasing. Why is it decreasing? Go ahead and pause the video here to think about what would cause the balloons, the number of balloons, to be decreasing as the party goes along. Hit play when you're ready. Well, I would say one of 3 things might be happening. You could have a balloon or several balloons that are popping. Okay, that either intentionally or not intentionally. We know that could happen. Okay? Also, especially if this might be an outdoor party, someone might be letting go of a balloon and there it goes. Hopefully not, because that's not great for the environment. But also, especially as we get towards the end or someone's got to leave, sometimes they just, hey, take a balloon with you. So all those are definitely good, viable scenarios for us to say why it might be decreasing. That's it for today. I'll see you next time.